to do your daggum IXLs. That's not good. Get your daggum stuff done on time. Makes life so much easier for you. Recording is good. We should be ready to go. All right, need your notes at the top of the page. You need to put 3.2. We did lesson 1. It should be right after the last lesson we did. We had 3 daggum pages of notes for the first lesson, did we not? This one should be nice and short, just 1 page, 3.2. 3.2. So we talked a little bit, as you're writing that down, you can go ahead and write those 2 tables down also for example 1 and example 2. Also put 3.2 and function notation at the top. But we talked about yesterday, the whole reason why we want to determine whether something is a function or not is because it's easy to graph, correct? All of chapter 2 stuff, slope-intercept form, point-slope form, standard form. We can use those formulas or those equations to figure out how to graph something, right? Say yes. Yes. We can find the slope, we can find the y-intercept and graph something, all right? So when we have a function, is it possible to graph it? Yes. Yes, all right? So that's all we're doing today is writing stuff in function notation, which is really just slope-intercept form. This looks a little bit different. Okay? Because can we graph something in slope-intercept form? Yes. We spent freaking over a month working on that. So we ought to be able to. Some of us can't, which is a problem, but you should be able to. All right, so the first problem is, okay, function notation, I just kind of talked about a little bit. It's the same thing as slope-intercept form, yes? Okay? You can write functions differently, but would you agree if I wrote this right here, if I wrote this problem in y-intercept form, mx plus b, you could make that into a graph? Would you agree? Okay? So we are going to create a function, okay, using this graph. This is something we didn't do a whole lot of last chapter, but we should have a pretty good idea how to do it. We did it briefly, I guess I should say. Okay? First of all, would you agree these are just a bunch of points? Okay, so if we graph those, could we graph those points and then figure out what the graph looks like? Okay, well, we want to figure out what the graph looks like without actually drawing the graph. Okay? So the first thing we're going to do is find the change in x over the change in y, which is just the slope, right? Okay, and the very first thing we learned last chapter is if you do have a table, you can just see how much the x's are changing by. How much are the x's changing by right there? 1. And how much are the y's changing by? It's 15. Whoever said that, good mathematical skills. Okay, so x's always come first, y's always come second. So if that's our slope, the change in y's over the change in x's, would it be 1 over 15 or 15 over 1? 15 over 1. Where would that go? Where b is or where m is? M. Right? So we got y equals 15 over 1 or just 15, right? Doesn't really matter. Okay, now we got to figure out where it crosses the. I kind of screwed up there. We got to figure out where it crosses the y-intercept. Does it show us? Yeah. Okay. What would be true? What number do we have to have up for here in order to be able to tell exactly where it crosses the y-intercept? What? Perfect. Good. If we had a 0 up there, boom, we know exactly. Well, we can figure that out on this one. These are just going by ones, right? So if they added another column over here, the next number would be what if they're going by ones? 0. And if these are going by 15s, the next number that way would be what? What's 17 minus 15? Boom. So where is it? When x is 0, what is the y-intercept? 2. So what would we put behind the x? 2. All right, say I couldn't figure that out. Say I couldn't figure that out. Now we'll do it on the next one right here, so we got an example. All right? So, what type of form is this written in? Slope-intercept form. They don't want that. They want it in function notation. So you ready for it? It's incredibly difficult. You ready? You ready, Aaron? Mind blowing. Anything different?
No.
What do they do? What's the only thing that's different? They replace y with, they can call that f of x. You just put f parentheses x in place of y. That is it. Don't let it blow your mind. Don't let it be confusing. That's all you can do. Now it's a function instead of slope-intercept form. That's it. Okay? But the key is, before you can put it in function notation, what form does it have to be? Or in other words, what has to be by itself? The y. Okay? You got to replace the y with f of x. Is that hard? Okay? What do you call that thing? F of x. You just put it in place of y. Nothing different. It's the exact same problem. They just have f of x there. It's the exact same thing as y. Don't let it blow your mind. Okay? Okay. What's the top changing on this one? 1. Okay. The bottoms are changing by 3. That's my slope. Okay. And let's say, just for funsies, we didn't know the next number over here was 0. Okay. We have no idea. There's no idea how we can figure out what 0 is. Okay. Well, do we know the slope of this? 3 over 1. Yes. What else do we also know from? What are these things right here? What? They're points. So can we put it in point slope form if we wanted to?
Yes.
Does it matter which set of points we use? It doesn't. Okay, but then from point slope form, could we put it in slope intercept form? So let's do it that way this time. So let's go y minus, let me erase this. Let's use this first one, this 1 and 1, because 1 would probably be pretty easy to do math with, huh? So my y number is 1. My slope, what did we say it was? 1 over 3 or 3 over 1?
3 over 1.
3 over 1, parentheses x minus 1. Now, can we make that into function notation yet? Because we got to get slope by, or y by itself, right? So I distribute. That gives me 3 over 1x. And 1 times a negative 1, sorry, a 3 times a negative 1 is negative 3. Now, can I put it in function notation? Move the 1 over, I add a 1 to a negative 3, that gives me a negative 2. So my final answer would be y equals 3 over 1x minus a 2. But is that my final answer in function notation? What do I got to change the y to? F of x. So we have to know how to do chapter 2 before we can do some of this stuff, don't we? Hopefully we see can do. Is function notation hard? It's just the same thing as slope intercept form, right? In other words, what letter you got to get by itself? Y, yes? All right, draw those two graphs real quick. Okay, you tore it up. We're going to put the diagram equations or lines in function notation form. So really, function notation form is slope intercept form, yes? So we got to find what two things? Slope and intercept ain't rocket science. Which intercept do we care about? The x-intercept or the y-intercept? The y. And what is the y-intercept? -3. So I'm going to go ahead and write f of x because I don't need the y there, do I? I need the f of x because I want function notation, yeah? Right? Equals, we said the back number is -3. I got to figure out the slope. Well, does this line already have 2 points on it?
Yes.
So you just start at 1 and go up. 1, 2, 3. I go up how many? 3. And I go over 1, 2, 3. Up 3 over 3 would be 3 over 3. How do we write? What's an easier way or a better way to write 3 over 3? 1 or 1 over 1, I'll just write 1. Okay, but why is my answer not 1 for my slope? Because it's what? Negative, because it's going down. Boom. Do we write in a function notation? Because function notation is the same thing as slope intercept form, yes? Holy moly, this is really hard. Let's try the next one. I'm going to put f of x because I don't want slope intercept form. I want function notation. What's my y-intercept? This negative, or this -2, or this what? 1, 2, 3, 4, 5. 5. It goes in the back. So I have 2 points on my line already. So now I can find my slope. If I didn't have 2 points on my line, what would I have to do before I could find the slope? Put 2 points on. You could, if you had 1, you could, or on the graph, if you have 2 points, could you make your own 2 points? Yeah. As long as they're where? On the corners, yes. On the streets. So I go up 5 and over 2. So would it be positive 5 over 2 or negative 5 over 2? Boom. Is that function notation? Mm-hmm. What's this crazy thing called? What if it was this? What would you call that? V of x. Cool. Write those two things down real quick. Exactly how I've written them. Now what do you think we're going to do with these? What? Oh, that's correct. But what's our goal here, you might? We started with a graph that last two columns. Now we're going to create a what? All right, so we're going to make a graph. Now, we have to have a slope intercept form in order to graph it, right? So, Addie was on the right page. Where does the x normally go in slope intercept form? Before the y-intercept or after the y-intercept? Before. So we need to rewrite that as negative x. What could I put in front of that x? A 1. Okay? And what should this 5 be? A +5 or a -5? What's in front of it here? What's in front of it here? Plus. So it's still +5. Did I move it across the line or anything? No, I'm just rearranging. Okay? It shouldn't change its values because I didn't cross the line. So I just rearrange that right there. Okay? Now could we go and graph that if we need to? Let's not go graph it. Right, let's save a little bit of time. So could we graph that if we needed to? Actually, we better because some of us are terrible at it. So I'll get graph. What am I going to put a dot at first? Some -1 somewhere or some 5 somewhere? That 5 tells you there's a dot at 5 on the what? That 1 tells you what? No, does not tell you -1 on the x. What in the heck does the -1 in front of the x tell you? It is the slope. Therefore, if there's just a single digit number, what does that -1 tell you the slope is doing? Tell me exactly what it says. How would you exactly do the slope? Somebody. Go down 1 over 1. Down 1 and over 1. How does he know to go down 1 and over 1 when there's just one number? How many numbers do you have to have in order to find slope? 2. You put it over 1 if there's not one, yes? -1 is the same thing as -1 over 1. So I go down 1, over 1. Should I go left or right? Why right? Gotta make a negative line. How many dots should I better daggone put? Better put tree. Should I just stop right there with those 3 dots and go all the way through my line? Yeah, I'm glad we did that. The sun was like, no sneaking clue. Function notation any different than slope intercept form? Only thing is just daggone f of x there, but you do it the same, yes? Alright. Does this next one look like slope intercept form yet? Nope, so we gotta do some mathematics. What's the first mathematics we should do? Definitely distribute. So we got 3x. What's that back number gonna be? 3 times 4, which is plus 12. Minus 7. Do I do the 3x minus the 7 or just the 12 minus the 7? That gives you 5. So we got 3x plus 5. So if I said, hey, go graph it, your first dot would be on the y-axis. Where at? 5. That number in front of the x tells you the slope is doing what? Up 3 what? Up 3 over 1. Since I'm already kind of at the top of my graph, could I go down 3 over 1? Where did you get to over 1? If you put it over 1, if it's not over anything, put it over what? 1. Can you just make up a number on the bottom? There's nothing on there. Just put it over 1. So I go down 3 over 1. 1, 2, 3 over 1. Why did I go left this time? Oh, okay. I went up 6, didn't I? 1, 2, 3, 4. Down 1, 2, 3, 4. Over. There we go. Function notation hard yet? You knew how to do chapter 2. It is not. It is not. It is not. It's not. Oh, it's not. Still have a little bit of room? Huh? Burley? Good. Maybe for like 3 quick examples? All right. All right, so the last part of this is the whole reason why they put the f of x there. All right, they're going to say solve for, or solve these equations for f of 4. Okay, so let's do 3 examples here. And they're going to have a function where f of, well, let's go ahead and do that. F of 4 equals 3x plus 5. That's the last one we just did. And let's do an example. We do f of 4 equals negative x, well, plus 5 a while ago. And let's do one more. Cool, fancy one, maybe let's go f of 4 equals 1/4 x minus 7. How about that? All right, so you heard those words from my mouth. I didn't say f of x anymore. I said f of what?
4.
Because I replaced the x with the what? 4. So this is incredibly difficult. If I want to solve for f of 4, what do you think I replace the x with?
4.
Holy moly! I just plug this into what? And do the math. That's it. So 3 times 4 is? Oh, literally write that so it doesn't blow your mind if you forget sometime. And then 12 plus 5 gives you 17. Now, could they put any number? This time, could I put 17 if I wanted to? Yeah. And what would I put in place of x? 17. All right, so we did 4 on all of them this time. So we got negative 4 All it is right there, plus a 5. What's a negative 4 plus a 5 give you?
1.
Oh, uno. Boom. You're done. What am I going to put in place of the x on this last one? 4. That's 1/4 times 4. 1 times 4 is? 4 divided by 4 is? That's 1 minus the 7, which gives you a negative 6. Function notation is a new term, but none of that stuff was new or hard or anything you have not done before. At all. At all. Get out your textbook to page 99. Huh?
Like a picture
The what?
of the
Oh. Page 99. We got 5 through 7 and 13 through 25. 5 through 7 and 13 through 25. They are easy peasy. We're going to do 4 problems together. Now we're going to jump around here. Okay? Just so we're going to do an example of each type of problem, but just make sure you're following along. You have an idea how to do each one of these, so you're good to go. So we're going to start with number 5. You got it right now, 5 through 7, 13 through 25? And we'll start with number 5. Now they give you a function in function notation, do they not? Is it 4x minus 3? Okay, and they say solve when x equals what in the directions? 2 and, so how many different answers are we going to have? 2. So the first one we're going to do is f, we're going to replace x with what? 2. So you do f of 2 right there. Right? If it's a really easy problem, I'm fine if you just do it in your head, but you have to put f of 2 there. So when I know, when you plugged in 2 for x, you got what? So on this one, we should be able to do in our head, 4 times 2 is, and 8 minus 3 is 5. Boom. So f of 2 on number 5 equals 5. That's your answer. That's exactly how it should work. Okay? Where if it was point slope form, what we would have done is we plugged x in for 2 and y in for 5. That's how we would write that. Point slope form or whatever. But they want function notation, so that's what it is. The next we plug in 5, and 4 times 5 is 20. 20 minus 3 is 6. Sorry. 6 times 4 is 24, and 24 minus 3 is 21. Function notation looks like that. It said slope. When we plugged in a what? We plugged in 6, we got a 24. Okay. We know how to write it there? All right. Skip on over to number. You can write it right after this one. There's not a problem. I have no problem with that. Let's go 19. 19 actually might be. Yeah, we'll probably do 22. Number 19. 19. Easy peasy, lemon squeezy. They want it in function notation form. Isn't that exactly what it tells us to do? It actually says write a linear function. Okay, so you don't have to do it slope, or you can do it in slope intercept form or function notation form. It doesn't really matter. Just the y is different. So let's find the slope first. How much of those x is going by each time? 1, yeah? So x is 1. How much is the y going by? Would you agree it's 5? So it's 5 over 1. Check! On maybe the next 2. If your numbers are getting smaller, what's it going to be? A positive or negative slope? Is it number 20? Isn't those y's getting smaller? Okay? So check that. So your slope's going to be negative on number 20. Don't mess that up. So our slope, we said was 1 and 5. Would it be 5 over 1 or 1 over 5? 5 over 1 is correct. And we don't have to do anything on this one to find the y-intercept. What is it? It's easy to see. It's easy to see. It's easy to see. -1, because x is 0, what is y? -1. You do nothing. You just look for the 0 and plug what for your slope intercept? -1. See that? So on number 20, what's your intercept? 4. On number 21, what's your intercept? On number 20, what's your intercept? On 21, what's your intercept? Yay! That's it. That's all I asked for on that one. We're done. Can we do 20 and 21 now if we needed to? All right, last example. We're going to do the hard one on that next section. I think it's 25. Yeah, 25. Again, they want to sketch this line. Well, before we can sketch it, what's it got to look like? Y-intercept form. So we got to get the x in front and everything else in the back, yes? So we got 0.75 times 10 minus x, parentheses, what's the back number? +1. So what do we do first here? Definitely distribute. 0.75 times 10, you could plug in your calculator, but I'm telling you right now it's 7.5. It's going to be a little hard to do some math here in a minute because you got dang decimals in here, but we'll survive. And then that's minus the -0.75x plus 1. So do we add the 1 to the 75x or the 7.5? It's a positive 7.5 and a positive 1, which gives you 8 point. Hey, we know a little bit of math. All right. So is that 8.5 the y-intercept or the slope? The y-intercept. So I'm going to go ahead and just write it in the back. 8.5, because then, isn't that where I want the y-intercept and slope-intercept form? Okay, and what is my x, or the number with my x, I guess you could say. The slope, which is not just 0.75, but -0.75. So all I'm doing is doing some rearrangement so I get the slope-intercept form. Now that's a wee bit of a problem, because my slope is 0.75. How in the heck am I going to do rise over run over that? Huh? What is 0.75 of the fraction, Jason? You know? 3 over 4. 75 as a fraction is 3 over 4. So my rise is what? 3 minus 4. 0.75 and 3 over 4 are the same thing, so I just switched that around. If you get a decimal like that and you have a question, then you can ask. But the whole point of these type of problems is to get it in slope-intercept form, right? Now I did it. Now what are you going to have to go do? Finish this problem. Graph. I'm not graphing it for you. You can go sneak and graph it. Okay? Start your assignment. I'll hand you out the graph paper you can use. And we're off and rolling. Have questions, ask. There ought to be a textbook laying around over yonder. Everybody get a graph paper. Yep, good question.